Hi, good morning. In today's video, I'm going to do this problem. This is International Mathematical Olympiad of 1977, problem number 6, okay? Let f of n be a function defined on the set of all positive integers and having all its set values in the same set. Prove that if we have this condition, we have for all positive integers f of n plus 1 strictly superior than f of n, then for all integers, okay, f of n equal to n, okay? This is the most challenged problems of International Olympiad. I'm going to transfer this given information into expression, okay? So as you see here, you have this information, all positive integers and having all its set values in the same set. What does it mean? That means all input numbers that you have in the set, it will have the same output in the same set. For example, we have this one. This is n, the set, you have input numbers 1, 2, 3, and so on, until you get the last term n. The outputs of these numbers are keep repeating the same. It will be the same. We will find 2, 1, 3, 4, and so on. Okay? This is f of n. This is output of these numbers. The output of these numbers, it will be the same number, okay, that you have in output. But I cannot say f of 1 equal to 1, f of 2 equal to 2, f of 3 equal to 3, or f of n equal to n, okay? Because if I knew that, they wouldn't give us proof f of n equal to n, okay? This is the main goal of this one now. I'm going to prove this one now. In order to do that, okay, I have two cases here. I'm going to suppose that f of n strictly superior than n, I will find contradiction. Then in the second case, I will suppose that f of n strictly inferior than n, I will find contradiction as well, okay? At the end, I'm going to say f of n equal to n because I have both contradictions, okay? So now, let's start. Let's start this information. What does mean all its values in the same set? That's mean you have the sum of these numbers. K goes from 1 to n equal to f of k goes from 1 to n equal the same time. I'm going to apply the function f on both sides. Is given as now f of k, okay? This is true as long as you have this is true. As long as you have a sum of k equal to the sum of f of k, this one is true as well because we are applying the function f on both sides with quality, okay? So we are not applying f on the inequality. Inequality, we are going to look at this function is increasing or decreasing. If it's increasing, if it's decreasing, the inequality is going to go to change the direction, okay? But in inequality, it will be the same. This is the difference, okay? Now, this is very important to keep this equation, okay? This equation is a whole thing. If you understand this, this meaning of this information, you will have this equation and you will use it and then you find the solution of this problem, okay? Okay, now I will have two cases. The case number one, I suppose f of n strictly superior than n, okay? I have this information for all integer, for all positive integers. I have f of n plus 1 strictly superior than f of n, okay? So I'm going to insert terms into this one. Term number 1, f of 2 superior than f of strictly superior than f of 1, f of 3 strictly superior than f of 2, and so on until I get the last term f of n strictly superior than f of n, right? I'm going to do the sum of these numbers. So that means I have sum of f of k. K goes from 2 to n plus 1, strictly superior than sum of f of k. K goes from 1 to n, right? This one I can rewrite it in this form. F of k, k goes from 1 to n minus f of 1 plus f of n plus 1, strictly superior than sum of f of k. K goes from 1. Why I made this change? Because I want to make it on this form, k equal to 1, okay? So that's mean k goes from 2 to n plus 1. I can rewrite it. K goes from 1 to n, but I can rewrite this one on this form. Instead k equal to 2, and I'm going to do the sum of k equal to 1, but I have to subtract f of 1 from this sum, okay? Plus the last term f of n plus 1, I can put it separately, okay? Now, as you see here, this information that I have here, okay, I have sum of f of k equal to the composition of f of k, okay? I'm going to switch this one by this one. So the sum of f of k goes from 1 to n. Okay, now I will have the cancellation. That's my goal, why I changed and made this change, okay? So now cancel out this one. So what's left? It will be f of n plus 1, strictly superior than f of 1, because I'm bringing f of 1 to the other side, okay? Now this is the first equation that I have now from this information, okay? Let's move on to confirmation. Okay, I get arrived here for all positive integers, f of n plus 1 strictly superior than f of 1. I'm going to work on this one now by inserting the terms n from 1 to n, okay? So this one equivalent f of 2 strictly superior than f of 1, f of 3 strictly superior than f of 1, f of 4 strictly superior than f of 1, and so on until you get the last term f of n strictly superior than f of 1, okay? I'm going to do the sum of these numbers. The k goes from 2 to n, the sum f of k goes from 2 to n, k goes from 2, I'm going to do the sum of these numbers. The sum of f of k goes from 2 to n, and then the right hand side of this inequality, how many times f of 1 here? We have n minus 1 times, because the k starts from 2 to n, okay? So that's mean n minus 1 f of 1, right? Now I have this information. Now I have of sum of k goes k strictly superior than n minus 1 f of 1, k goes from 2 to n, okay? I can rewrite this one as f of k goes from 1 to n minus f of 1, okay? And this I have strictly superior than n minus 1 multiplied by f of 1, okay? So this one is given as f of k goes from 1 to n. I'm going to bring f of 1 to the other side, n minus 1 f of 1 plus f of 1. I'm going to factor, take the f of 1 as a multiplier of this one, so f of 1 n minus 1 plus 1, okay? Cancel out number 1, so this means f of 1 and f of 1, okay? So that's mean, as you see here, what is this? f of k, we have it in this information before. Since we know, since we have f of k goes from 1 to n equal the sum of k from 1 to n, okay? This implies I'm going to replace this one by this one, okay? So this implies f of k goes from 1 to n equal the sum of k goes from 1 to n strictly superior than this one, n for 1, okay? Okay, I'm going to clean the board and bring this one at the top and continue with our problem, okay? I get arrived to this one, sum of k goes from 1 to n, strictly superior than n of multiplied by f of 1. I have this given information, f of n plus 1 strictly superior than f of n. I'm working on this one, okay? I already supposed that f of n strictly superior than n. I'm working on this one. I'm still in the first case, okay? So now, equivalent. What is this? I want to tell me what is this. This k goes from 1 to n. We already have it equal n plus 1 over 2, okay? This one we have it already. This one, sum of k equal n multiplied by n plus 1 over 2, okay? It's very famous one, okay? So I don't have to prove it now, just easy, just apply, okay? So this one can replace it by this one. So we have n over n plus 1 over 2, okay? Strictly superior than f of 1. I'm going to cancel out n from both sides, okay? This one equivalent n plus 1 over 2, strictly superior than f of 1, okay? So now, as you see here, you have f of n, we have two inequalities. f of n strictly superior than n, equivalent. I'm going to plug the n equal to 1 into both inequalities to see. For n equal to 1, this implies equivalent to equations. I have plug in 1 plus 1 over 2, which is 1, strictly superior than f of 1. The second inequality will have f of 1, strictly superior than 1, okay? What is this? You have 1 superior than f of 1. In the same time, f of 1 is superior than 1, okay? As you see here, this is both equations. This is contradiction, okay? This is contradiction. That means f of n strictly superior than n is not verified by absurd, okay? By absurd proof. Now we have proved the first case. I'm moving on to the second case, okay? Now in the second case, we are supposed that for all integers n, f of n strictly inferior than n, okay? I'm going to work on this one. I will find the contradiction, okay? Again, so as you see here, let a sub n be a sequence, okay? So this one we put as a substitution, a sub n equal to f of a and minus 1, minus 1. Okay? I'm just doing the substitution. Don't forget, if n equal to 1 here, right? Now this is condition, you have to put, for example, a sub 1 equal to f a sub 0 minus 1. Okay? So a sub 0 minus 1 has to be strictly superior than 0 because we are working, our integer has to be positive integer. Okay? That's mean inside of the function it has to be strictly superior than 0. Okay? Whatever you have inside of the function, okay, as a input number. So that's mean a0 strictly superior than 1. Okay? This is the condition that you have. So now I'm going to do the substitution and plug in this one into this one now. Okay? So we have f of n plus 1 as a given information. f of n. Okay? This is for n equal to 1. So this one equivalent let's put this one inside this one. So this one is giving us, let's replace n by this one, an minus 1 plus 1, strictly superior than f of n. I'm going to plug in number n by this one as we have here. So an minus 1. Okay? So equivalent, going to cancel out number 1. 1 minus 1 equal to 0. f of a sub n minus 1 strictly superior than f of a sub n minus 1 minus 1. Okay? What is this? We have this as a substitution. Okay? f of a sub n. Okay? Now I have an equality, f of a sub n minus 1 strictly superior than f of a sub n. Okay? So this one, what the information this one is giving you? This one also, f of, let's plug this one into this one, and equal to, for example, 1, a0 superior than f of a sub 1, a sub 0 superior than sub 1, and superior a sub 2, as you see if you plug in, and so on. Decreasing function. Okay, for all integer number positive, because we are working on the positives. Okay, so let's move on. Let's clean up the board and move on to the, since we have f is decreasing function. Okay, so now I have this equality. Since I have the f is decreasing function, okay, so for all integer n, I have f of n strictly inferior than n. This one equivalent f of n, because I'm applying the function on both sides because I have decreasing function. This one is going to change the direction. Okay, I'm applying, since I have f is a decreasing function, I have this f of n strictly inferior than n for all integer n. I'm applying my function. When I'm applying the function, the inequality is going to change the direction because you have decreasing function. Okay, as you see it here. Okay, another information here, what we have here, since we have for all integers and positive integers, we have f of n plus 1 superior, strictly superior than f of n. I have also this f of n, this which is this one, strictly superior than f of n. Okay? What does this mean? This one superior, strictly superior than this one. For all integers, f of n plus 1 strictly than f of superior than n. Okay? This one strictly superior than this one. Since I have this function is a decreasing function, okay? What does this mean? This inequality, when I take off the function from both sides, the inequality will be changed the direction as well, okay? So that's mean my direction n plus 1 inferior than n plus 1 strictly inferior than n. This is contradiction as well. This is contradiction. Okay, let's move on to summarize this one. Okay, so let's summarize this one. In the first case, for all integers n, f of n strictly superior than n, we found contradiction by absurd. Okay, in the second case, for all integers n, f of n strictly inferior than n, we found contradiction by absurd proof. And finally, for all integer n, f of n equal to n. Okay, so this is the good place where I can stop. Thank you for watching. I will see you in next video. Bye.